Ladies and gentlemen, welcome back. 1.1.1, we are asked to solve for x, and the first one is x minus 3 equals to 0. First up, a nice easy one. We are going to apply the zero product rule, which says if a times b is equals to 0, then either a will be equals to 0 or b would be equals to 0. So in this case, our a will be x, which is the first bracket. So we're going to say x is equals to 0, or the second bracket, which is x minus 3 is equals to 0, which is going to simplify to x equals to positive 3. And that is our answer for 1.1.1. Now let's go to the next one. The next one, we are asked to solve for, it's 1.1.2, and it's 2x squared plus 1 equals to 4. And we are told that to solve, correct to 2 decimal places. Ladies and gentlemen, if you see a question saying correct to 2 decimal places in question 1, they are just telling you use the quadratic formula. Before we can use the quadratic formula, we are going to bring all the terms to one side, which is going to be 2x squared minus 4x plus 1 is equals to 0. Now, let us use the quadratic formula, which is x is equals to negative b plus minus b squared minus 4ac all over 2a. I'm using this because the question said I must round off to 2 decimal places, which means my roots are going to be irrational. And I'm sure, ladies and gents, you can see that our a is 2, our b is minus 4, our a is 1. So now let's substitute that into our quadratic formula. So we are going to have x, I prefer the white color. So x will be equals to minus, the b is minus 4, plus minus, minus 4 squared minus 4. Our a is 2, our c is positive 1, all over 2 multiplied by 2. And putting that into the calculator, we are going to get x is equals to 1.71 or x equals to 0.29. Some learners show the steps when they after this they show another step which is unnecessary. After substitution, just give the answers. So this is how they are going to mark for you. So you are going to get a mark here, a mark there, a mark for substitution, and a mark for writing in standard form, which should be 4 marks in total. All right, sometimes it's 3 marks. All right, let me check how many marks was this one specifically. Let's see. Okay, let's check here. Oh yeah, that was 4 marks. All right. Now let's go to the next one. The next question, let's see. We are just asked to solve, which is 1.1.3. We are given x squared minus 2x minus 3, which is bigger than, let me write my x nicely, which is bigger than 0. First, solve the quadratic as an equation to get the critical values. So see this, we are going to say x squared minus 2x minus 3 equals to 0. And then we factorize, which is x minus 3, x plus 1 equals to 0. So we can see that applying the zero product rule, the first bracket will be equals to 0, or the second bracket must be equals to 0, which means x must be equals to 3, or x must be equals to minus 1. All right. And then from there, we need to draw a number line with critical points at -1 and 3. We always start with the smaller one and then the bigger one. Let's do that. Here's our number line. You show the smaller one, you show the bigger one, right? And then our critical points, let's go back up, are going to be unshaded. Why? Because the inequality sign doesn't have or equals to. So our critical points are open circles. Ne? If this was that, we're going to draw solid circles. All right. Now let's test. Ne? We are going to test the intervals, right? Usually I do my testing on the side with a pencil. Ne? I can see that this number line is divided into 3 regions. The first region is here, the second one is in between, the third one is there. We can agree, ladies and gentlemen, that 1 and 3 will always, not necessarily, actually let's do this. Region 1, we can see that it's x, I prefer the white one, x is less than -1, right? Or the second region is between -1 and 3, so it's going to be -1, x, 3. Or the third region is just x bigger than 3, right? You don't have to show that. It's just to help you. So your answer is either one of these 3, at least one of these 3 intervals, right? We need to find out. Ne? So for example, let's pick any x value less than -1. Okay, here I'm going to pick x -2 and substitute it into our equation. Ne? Okay, so I pick -2. So I'm going to have -2 squared -2 -2. Remember, you are using a pencil here, right? Then -3. The answer would be 5, which is bigger than 0. And if you look at the question, we are indeed looking for bigger than 0. So we can agree that the region 1 is going to be part of the solution. So I'm going to box it in purple to show that we are taking it. Okay? Let's now pick any number between -1 and 3. The easiest one is 0. Now let's substitute that into our equation. Our equation, remember, it's going to be 0 squared -2, 0 -3. This gives us how much? This will give us -3, which is less than 0. But remember, we are looking for bigger than 0. So if we're looking for bigger than 0, but whatever region we get, which we have, gives us less, it's not going to be part of the solution. So we'll remove it. All right. And then let's pick any number between that is bigger than 3. Obviously, I'll take 4. Ne? So I know that I'll have 4 squared, then -2, 4, -3. The answer is 5, which is bigger than 0, which is indeed a solution. So your solutions are going to be these 2. All right. Thank you very much, ladies and gentlemen. I hope that makes sense. I hope that makes sense. Let's go on. Okay, white. Next question. What do they want us to do? Okay, it's 1.1.4. All right. Let's check 1.1.4. So 1.1.4, we are given 2 to the power 2x minus 2 to the power x plus 2 minus 32 is equals to 0. Right? All right, legends. Let's tackle this exponential equation. It might look scary, but we'll simplify it nicely. All right. Firstly, I need us to split. Let's split 2x plus 2. Ne? Let's split that. We can agree that that is going to be 2 to the x multiplied by 2 to the 2, which is basically 4 multiplied by 2 to the x, because this guy here would be 4 times that. All right. So we can agree that therefore the equation becomes 2 to the 2x minus 4 multiplied by 2 to the x minus 32, which becomes 0. Now we're going to let the smallest exponent between this one and that one to be k, which means we're going to let the middle one, which is 2 to the x, to be equals to k. Therefore, we can agree that 2 to the 2x can be written as 2 to the x and then with a 2 outside, right? Because this times that will just give us that. Okay? Which becomes k to the power 2 because we just made this to be k. All right. So we're going to substitute the k's back now. Can agree that this guy will become k squared. So in the equation we have k squared there. So k squared minus 4k because this guy becomes k. And then minus 32, which will be 0. And then we can see that this becomes a nice trinomial that is very easy to factorize. So let us factorize this. We have k. We're going to have plus 4 minus 8. Therefore, we can see that k plus 4 will be 0 or k minus 8 would be 0 by zero product principle. Okay, let's write the 8 properly. Will be 8. All right. But we need to know that the k cannot be negative because 2 to the power x will always be bigger than 0. So we are going to say, okay, k is not equals to minus 4. Why? We can show here because 2 to the power x will always be bigger than 0, no matter what the value of x we put in there. Remember, k is basically 2 to the x. Or this side we're going to have k equals to 8. But remember, k is 2 to the x. 8 can be written as 2 to the 3. Therefore, x equals to 3. And that is the solution for 1.1.4 of this question paper, ladies and gentlemen. Now we need to do 1.1.5. Let's see, 1.1.5. So on 1.1.5, we are asked to solve for x, given this, right? Which equals to, oh sorry, there's minus x here, equals to 2. Remember this before we go, ne? Square root equations always needs checking. Ne? So what I do before I even start is this, ne? To write my restriction. I know that whatever is under the root can only be positive or equals to 0. It cannot be negative. Otherwise, we're going to have undefined. No, I mean imaginary roots, not undefined. Undefined is division by 0. So if whatever is underneath the root is negative, we are going to have imaginary roots. So we don't need that. So we must show the restriction. So we have minus 2x is bigger or equals to minus 4. And we can see that x would be less than or equals to 2. Remember, when we divide by a -2, the inequality sign will move from there to here. It switches the direction because we divided by a negative number. So which means as we solve this question, we are only going to accept the values of x that are either less than or equals to 2. Anything bigger than 2, we are going to cancel it out. It's not going to be part of the solution. Right. So, ladies and gentlemen, now let's solve. We can agree that we need to isolate the root. Therefore, the root must be isolated. So, which is minus 2x plus 4 is equals to 2 plus x. All right. I just moved the minus x to the other side. And then we now have to square both sides. Let's square both sides. So square and square to remove the root. So this square root cancels with the 2. We left with minus 2x plus 4. But ladies and gents, I don't advise you to show the cancelling. You must just do it in your brain. So just write it neatly like that. And just say we have minus 2x plus 4. All right? Is equals to this bracket here. We have 2 plus x and another 2 plus x. This will expand to x squared plus 4x plus 4. All right. So you need to be quick with expanding, right? This is a grade 9 topic. If you are not good with that, please go and do revision. And then we are going to bring all terms to one side. So we're going to have 0 is equals to x squared plus 6x. And then we need to now factorize. You can see that this guy and that guy are going to cancel. So this guy and that guy, this will add there. Perfecto. Now let's factorize this. 0 is equals to x, is equals to x. And then we're left with x plus 6. Applying 0 product, we know that the first bracket will be 0 or the second bracket will be 0, which gives us x equals to minus 6. All right. But remember, what did we say? We said x must be less than or equals to 2. So let's see here. Does minus 6 work? Let's check. Minus 6. Let's see. I might have made something wrong here, because minus 6 doesn't work. So, and also, ladies and gents, we need to acknowledge that x must be, let's see. Let's check this. Okay, the best advice to give you, let's remove this and we're going to check them manually. I think that is the best advice I can give you, right? If I were to put in 0 here and test, I'm going to replace this x with 0 and that one with 0. I indeed get square root of 4, which is 2 and 2. So x equals to 0x. But let's see if x is minus 6. If x is minus 6, here I get 10, and then I get square root of 16 plus 6, because it's going to be minus 6, so it's going to be plus 6. Square root of 16, which is 4, so I'm going to get 10 this side in total, which is not equals to 2, so we're going to remove that. All right. let's do that. So x can be that. All right, awesome, ladies and gentlemen. So the most important thing is to always check for extraneous solutions in radical equations. Don't forget, that's where many learners lose their points. When they get the answers, they just leave them like that. Always check your answers when you're working with the root equations. All right. Now let's do 1.2, which is the simultaneous equation. So the first equation was 2x plus y is equals to 3. The second one was y squared plus xy is equals to 2. From first equation, I'm going to call this 1, then we're going to call this 2. Ne? So I'll say from 1, which is from the first equation, we can see that we can rewrite that as y is equals to 3 minus 2x to make y the subject of the formula, which is the simplest one to pick in this case. You always pick the simplest one and you make it the subject. No? Which means I'm going to replace this y and that y with 3 minus 2x because we're saying y is that. So I'm going to say subs y into 2. So you can see where I see y I'm going to replace with 3 minus 2x. So I see the first one, 3 minus 2x squared, and you can see, ladies and gents, I put brackets always. And then we get 2 there. Right. And then now, ladies and gentlemen, we need to expand. So we have 9 minus 12x plus 4x squared. This is what this bracket is going to expand to. Right? And then we have plus 3x minus 2x squared is equals to 2. Right? And then we need to now simplify. We can see that we're going to be left with 2x squared because this one and that one goes together. And then we're going to be left with minus 9x because this one and that one goes together. And then we're going to be left with plus 7 because, okay, let's do this. Plus 7 because this one will be subtracted by that one, which is equals to 0. And then from here, ladies and gentlemen, we can factorize, which is going to be 2x and then x, right? And then let's see, we are going to have minus 7 minus 1. We can see by 0 product that will be 0 or that will be 0. So the first bracket will be 0 or the second bracket will be 0. Then this solves to 2x equals to 7. Then we can see, ladies and gentlemen, by dividing both sides, we get x equals to 7 over 2 or x equals to 1 by moving 1 to the other side. Now we need to find y. Therefore, remember, we had an equation like this. Y was equals to 3 minus 2x. From this, we can get our y values. The first one will be y equals to 3 minus 2. Where I see x, I put 7 over 2. Or the second one will be y is equals to 3 minus 2. Where I see x, I put 1. Because the x value there was 1. The x value there was 7 over 2. Or 3.5. Someone can write 3.5. It's also allowed. And this 1 will give us minus 4, and then the other one will give us y is equals to 1. All right. And some people prefer to write it in coordinates form, which is going to be 1 coordinate 1 and or you must always put or 3.5 of, if you want to, you can say 7 over 2 coordinates negative 4. Right, you get it, ladies and gentlemen. And then boom, that's how you tackle this exam questions step by step. Remember, practice makes permanent, not perfect, but permanent. Keep grinding and check out the 2-in-1 maths plug for more lessons. Drop a like, subscribe, and keep those pencils sharp. Until next time, maths never sleeps. Thank you.